So, welcome back. So, having seen the schematic of Mollier diagram or Mollier chart or enthalpy entropy diagram, let us now have a look at the actual Mollier diagram itself. So, what I will do, I will explain this Mollier diagram and then we can solve a small problem in order to demonstrate the usage of this Mollier diagram. So, let us look at this slide, and what you see here is the actual Mollier chart or Mollier diagram or HS diagram. You can see on the y axis we got an enthalpy in kilojoule per kg, on x axis what we have is an entropy S in kilojoule per kg Kelvin, and here what we see is the Mollier chart, where you can see that this line is saturated liquid line where x is equal to 0, and this line is x is equal to 100%, what you see from here. So, I can show you 2 points, x is equal to 0%, which is this line, and x is equal to 100%, which is saturated vapor line. Both these lines, x is equal to 0, x is equal to 100%, they meet at the critical point, alright. So, I got all the information available on the saturated liquid line and saturated vapor line. Also, what you can directly see are the different x lines over here, different dryness fraction lines, constant dryness fraction lines. So, x equal to 10%, 20, 30, 40, 50, 60, 70, 80 and 90, and in between these you can interpolate. A graphical interpolation may not be accurate, but that is sufficient, that is fine to convey us what it should. Also what you see here are the different pressure lines, alright. So, we can see the blue lines are the pressure line, P is equal to 1000 bar, 600 bar, 100 bar, 10 bar, 1 bar, 0.1 bar and 0.01 bar. One can interpolate between these two pressures also. Also what you see are the temperatures which are given in Kelvin over here, while they are also been given in degree centigrade over here. Then we got a specific volumes, meter cube per kg, which are showing in this red letters, alright. So, from here I can get lot of information for any state, and just to demonstrate, for example, we got a 1 bar, I can go and see this closely, I can go down here, and if I enclose this even pressure, one can see that, alright. So, you can see this 1 bar blue line, it comes over here and meets at 373 Kelvin, which is 100 degree centigrade, alright. So, one can see that at 1 bar you got a Tsat value which is equal to 100 degree centigrade, and if I come down you can also see these values closely. Similarly, at various pressures, at various temperatures, again I can see and I can read the properties like this, alright. Similarly, I can read the entropy corresponding to given point. Let us now locate one point in order to just demonstrate how do I extract values from this graph. Let us have a point like this, and let us go close to the point and try to see different things one can see from this. So, one can see from this graph that this point is x is equal to 0.9, alright. Also, if I see this in this direction, I can see that this is 323 Kelvin, close to that. So, temperature is equal to 50 degree centigrade, this is 100, and therefore, I can say that this is 50 degree centigrade, T is equal to 323 Kelvin approximately, and corresponding to that I can see the pressures which is around 0.1 kind of a thing, alright, approximately. Also, if I draw verticals, I can see the entropy will be somewhere close to 7.5, just less than 7.5 maybe, because this is 7.5 point. And also I can read the enthalpy. If I draw a horizontal, I can get a value between 2000 to 2500 somewhere here. Also one can read various other properties like specific volume, etc. Alright. So, one can get all these values from here, and I can show those values as drawing horizontals, drawing vertical, Yeah, so I can say that the entropy could be around 7.3 or 7.4, and this is 2350 and this is 7.4. So I can show you here that the properties are T is equal to 50 degree centigrade, X is equal to 0.9, H is equal to, the enthalpy is equal to 2350 kilojoule per kg, and S is equal to 7.4 kilojoule per kg Kelvin. Similarly, one can find out other values like specific volume, etc. Alright. So, a lot of information has been conveyed from this chart, and one can especially use this when you want to refer to processes or some cycles that could be shown directly on the Mollier chart, and one can therefore see what part of this cycle lies in a two-phase region, a single phase region. Accordingly, one can get a lot of knowledge about the cycle itself or about the process itself. So, various applications of Mollier diagram: visualization of working cycles of thermodynamic systems, of which I just talked about. The vertical lines are isentropic processes, the horizontal lines are isenthalpic processes, and as soon as you see a cycle which has got vertical lines or horizontal lines, one can always understand the isenthalpic and isentropic processes over here. The isobaric process, constant pressure processes where the heat interaction Q is equal to delta H, and one can use this information for design of steam turbines, compressors, refrigeration systems and air conditioning equipment. So, what have we learned from this? We have learned about the Mollier chart, we have found out the salient features of Mollier chart, and we have seen in short the applications of Mollier diagram. Thank you very much.